And speaking of servers, let's take a look under the hood of our latest innovations in server infrastructure. I talked about this at Ignite, the way that we've been shifting a lot of computing for our network and storage stacks from our hosts onto accelerated offload cards. So this is a big shift you're seeing in the way that servers are designed, really driven by cloud computing, where we're trying to optimize the serving of these very expensive cores to customer workloads, and then running some of the infrastructure processing on lower cost, lower power cores. Specifically in our case, with this offload card that we've got an FPGA, which is dynamically programmable. It's field programmable gate array, which is where the data flows for our network and storage stacks flow. We've been using FPGAs in Azure since the early 2010s with the introduction of accelerated networking, and now we're accelerating our storage on top of those FPGAs as well. This is combined with a system on a chip, which is ARM-based cores, running a Linux operating system, Mariner Linux, also known in one version that I'll talk a little bit later with the new name that we've announced here at Build. And that is where the agents, the control plane, and other agents that support that computing that's happening on those FPGAs happens. I happened to have one example of those cards right here that I thought would be interesting to show. Just so you can see what we're putting on our servers. This actually is the next generation of the cards that we're got in our servers today, the one that I'm talking about right now. So this one we haven't actually started to roll out across our fleet yet. It represents the next generation and next jump in capabilities of our hardware infrastructure. Now, one of the benefits of using FPGAs is that we can dynamically upgrade our infrastructure without changing out the hardware. And I've actually got a very concrete example of how we're taking advantage of that with our new EBS v5 virtual machine sizes. I talked at Ignite about our new, at the time, EBS v5 generation virtual machines that use these accelerated offload cards, providing more IOPS and more bandwidth or throughput than the previous generation of virtual machine sizes, the EBS v4s. We've upgraded the code on the FPGAs on the exact same hardware and have improved the performance of the EBS v5 when it comes to storage by 2.5 times, which is 8 times more performance than the previous generation EBS v4s. So if you're running an EBS v5, you will either already have been upgraded to this performance level or will be soon because we're rolling this out across the fleet. The number of IOPS we deliver is cloud leading at 400,000 IOPS, and you can see 10 gigabytes of remote storage throughput. That's on top of a network adapter that supports 100 gigabits of throughput. Let's go take a look at a demo of that in action. So what I've got here on the left is the older generation of EBS5, and on the right is a virtual machine with the new version. And I'm running a tool here called Iometer. Iometer lets you drive storage operations on attached devices. In this case, it's virtual disks. And I'm going to kick off Iometer on both of them. And now, if you take a look at what we're seeing, it's 160,000 IOPS, EBS v5, the previous generation of it on the left, and the 400,000 IOPS that I talked about there on the right, on the upgraded version of that server. And I'm going to show you the throughput here with a tool called FIO, a Linux tool here, and I've got same thing, 2 virtual machines, current on the left, new one on the right, and you can see there's the 4 gigabytes per second that we're driving on the older generation, and the 10 gigabytes we should see here, and there it is, on the newer generation.